Both THHN and XHHW-2 conductors are suitable for cable tray installation. The National Electrical Code, or NEC, does not mandate that conductors be factory labeled as tray cable or TC for utilization in cable trays. However, employing TC-rated conductors can offer supplementary advantages such as amplified fire resistance and mechanical safeguarding. When utilizing THHN or XHHW-2 conductors in cable trays, specific considerations must be addressed. Firstly, conductor size must align with the necessary current carrying capacity for the circuit. Secondly, THHN conductors are appraised for use in dry or damp environments, while XHHW-2 conductors are appropriate for wet or corrosive settings. Thirdly, THHN conductors possess a maximum operating temperature of 90 degrees Celsius or 194 degrees Fahrenheit, while XHHW-2 conductors have a maximum operating temperature of 75 degrees Celsius or 167 degrees Fahrenheit. Fourthly, conductors must be sufficiently shielded from physical harm inflicted by other cables or equipment within the tray. Fifthly, conductors must be securely supported and fastened to the cable tray utilizing sanctioned methodologies. Sixthly, in particular instances, such as when fire resistance is obligatory, conductors may necessitate enclosure within conduit or raceway inside the cable tray. The ampacity of conductors installed in cable trays is governed by the National Electrical Code, specifically Article 392, cable trays. Several factors influence the allowable ampacity, including the conductor size, insulation type, ambient temperature, and the number of current-carrying conductors in the tray. For conductors rated 600 volts or less, the ampacity is typically determined based on National Electrical Code Table 310.15b16, with adjustments made for ambient temperature and the number of conductors. When multiple current-carrying conductors are bundled or stacked in a cable tray, a derating factor must be applied to reduce the allowable ampacity. The specific derating factors are outlined in National Electrical Code Table 310.15 Code. The distance between cable trays should be determined based on the specific application and the type of cables being supported. Generally, cable trays should be spaced to provide adequate support and prevent excessive sag or stress on the cables. The National Electrical Code does not specify a fixed distance between cable trays, but it does require that the installation be mechanically sound and provide sufficient access for maintenance and inspection. Cable trays should be supported at intervals that prevent excessive deflection or strain on the cables. The support spacing will depend on the cable tray design, the weight of the cables, and the environmental conditions. Consult the cable tray manufacturer's specifications for recommended support spacing. National Electrical Code Article 392.30 covers the requirements for cable tray installation. THHN, or thermoplastic high heat resistant nylon coated, is a type of electrical wire insulation commonly used in building wiring and conduit systems. It is a popular choice due to its versatility, durability, and resistance to heat and moisture. THHN insulation consists of a thermoplastic polyvinyl chloride, or PVC, layer for insulation on a nylon jacket for added protection against abrasion, chemicals, and moisture. The nylon jacket also provides a smooth surface for easier pulling through conduits. THHN wire is primarily used for general-purpose wiring in dry locations, as well as in conduit, cable trays, and raceways. It is suitable for both residential and commercial applications. The high heat-resistant aspect of THHN insulation means it can withstand higher temperatures than some other types of wire insulation. THHN is typically rated for a maximum operating temperature of 90 degrees Celsius or 194 degrees Fahrenheit in dry locations. However, it is important to note that the ampacity or current carrying capacity of the wire may need to be derated based on the actual operating temperature and the number of conductors in a conduit or cable. THHN wire is available in a wide range of sizes, from small gauge wires for lighting circuits to larger gauge wires for heavy-duty power distribution. The appropriate wire size depends on the current carrying requirements of the circuit and the applicable electrical codes. THHN wire is generally compatible with a variety of connectors, terminals, and splicing methods. However, it is important to use connectors and terminals that are specifically designed for use with THHN wire to ensure a secure and reliable connection. When installing THHN wire, it is important to follow all applicable electrical codes and safety guidelines. This includes properly grounding the electrical system, using appropriate overcurrent protection devices such as circuit breakers or fuses, and avoiding overloading circuits. XHHW-2 or cross-linked polyethylene high heat resistant, water resistant, is another type of electrical wire insulation commonly used in building wiring and conduit systems. It is known for its excellent resistance to heat, moisture, and chemicals, making it suitable for a wide range of applications. XHHW-2 insulation consists of a cross-linked polyethylene or XLPE layer for insulation. Cross-linking enhances the insulation's properties such as heat resistance, chemical resistance, and mechanical strength. The high heat resistant aspect of XHHW-2 insulation means it can withstand higher temperatures than some other types of wire insulation. XHHW-2 is typically rated for a maximum operating temperature of 90 degrees Celsius or 194 degrees Fahrenheit in dry locations and 75 degrees Celsius or 167 degrees Fahrenheit in wet locations. The water-resistant aspect of XHHW-2 insulation means it can be used in wet or damp locations such as underground conduits, direct burial applications, and outdoor wiring. XHHW-2 is also resistant to a variety of chemicals, making it suitable for use in industrial and corrosive environments. XHHW-2 wire is commonly used for power distribution, lighting circuits, and control wiring in residential, commercial, and industrial buildings. It is often used in applications where moisture or chemicals may be present. XHHW-2 wire is available in a wide range of sizes, from small gauge wires for lighting circuits to larger gauge wires for heavy-duty power distribution. The appropriate wire size depends on the current carrying requirements of the circuit and the applicable electrical codes. XHHW-2 wire is generally compatible with a variety of connectors, terminals, and splicing methods. However, it is important to use connectors and terminals that are specifically designed for use with XHHW-2 wire to ensure a secure and reliable connection. When installing XHHW-2 wire, it is important to follow all applicable electrical codes and safety guidelines. This includes properly grounding the electrical system, using appropriate overcurrent protection devices such as circuit breakers or fuses, and avoiding overloading circuits. In summary, THHN is a versatile and durable wire insulation suitable for general-purpose wiring in dry locations, while XHHW-2 is a robust wire insulation with excellent resistance to heat, moisture, and chemicals, making it suitable for a wider range of applications, including wet and corrosive environments. Both THHN and XHHW-2 are commonly used in building wiring and conduit systems, and the choice between the two depends on the specific requirements of the application and the applicable electrical codes. Cable trays are structural systems used to support and route electrical cables and wiring in various industrial, commercial, and residential settings. They provide an organized and efficient way to manage cables, protecting them from damage and ensuring easy access for maintenance and repairs. Cable trays come in a variety of designs, materials, and sizes to accommodate different cable types, weights, and environmental conditions. Ladder cable trays are one of the most common types of cable trays. They consist of two parallel side rails connected by rungs or cross members, resembling a ladder. Ladder cable trays provide excellent ventilation and easy access to cables, making them suitable for applications where heat dissipation and maintenance are important. Ventilated trough cable trays are similar to ladder cable trays but have a solid or perforated bottom instead of rungs. The ventilated bottom provides some ventilation while also offering additional support for cables. Ventilated trough cable trays are often used for supporting smaller cables and wiring. Solid bottom cable trays have a completely solid bottom, providing maximum protection for cables from dust, debris, and physical damage. Solid bottom cable trays are typically used in environments where cleanliness and protection are critical. Wire mesh cable trays, also known as basket cable trays, are made of welded wire mesh. They are lightweight, flexible, and easy to install. Wire mesh cable trays provide excellent ventilation and allow cables to be easily routed and accessed. Channel cable trays are typically used for supporting small quantities of cables or individual cable runs. They are often used in control rooms, instrumentation systems, and other applications where space is limited. Single rail cable trays consist of a single rail or beam that supports cables. They are typically used for supporting lightweight cables or tubing in applications where space is restricted. Cable trays can be made from a variety of materials, including steel, aluminum, stainless steel, and fiberglass. Steel cable trays are the most common and cost-effective option. They are strong, durable, and can support heavy cable loads. Aluminum cable trays are lightweight, corrosion-resistant, and non-magnetic. They are often used in applications where weight is a concern or where exposure to corrosive environments is likely. Stainless steel cable trays offer excellent corrosion resistance and are suitable for use in harsh environments, such as chemical plants, food processing facilities, and marine environments. Fiberglass cable trays are non-conductive, corrosion-resistant, and lightweight. They are often used in applications where electrical isolation is required or where exposure to corrosive chemicals is likely. Cable trays are typically installed using a variety of supports, hangers, and mounting hardware. The specific installation method depends on the type of cable tray, the cable load, and the building structure. Cable trays can be supported from the ceiling, walls, or floor using a variety of hangers and brackets. The support should be spaced according to the manufacturer's recommendations to ensure adequate support and prevent excessive deflection. When installing cables and cable trays, it is important to follow all applicable electrical codes and safety guidelines. This includes properly grounding the cable tray system, using appropriate cable ties and supports to secure the cables, and avoiding overloading the cable tray. In conclusion, cable trays are an essential component of modern electrical systems, providing an organized, efficient, and safe way to support and route electrical cables and wiring. The choice of cable tray type, material, and installation method depends on the specific requirements of the application and the applicable electrical codes. Proper installation and maintenance of cable trays are critical to ensuring the reliability and safety of electrical systems. The National Electrical Code, or NEC, provides comprehensive guidelines for the installation and use of electrical equipment and wiring, including cable trays and conductors. Adherence to the NEC is essential for ensuring the safety and reliability of electrical systems and for complying with local regulations. The NEC is updated every 3 years to reflect changes in technology, industry practices, and safety standards. It is important for electricians, engineers, and other professionals to stay up to date with the latest edition of the NEC to ensure that their work meets the current requirements. The NEC covers a wide range of topics related to electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for the selection, installation, and use of electrical equipment and wiring to minimize the risk of electrical shock, fire, and other hazards. Article 392 of the NEC specifically addresses cable trays. This article covers the requirements for the installation, support, and grounding of cable trays, as well as the types of cables that are permitted to be installed in cable trays. The NEC requires that cable trays be securely supported and grounded to ensure that they can safely carry electrical currents and provide a path for fault currents to flow back to the source. Cable trays must be supported at intervals that prevent excessive deflection or strain on the cables. The support should be designed to withstand the weight of the cables and any additional loads, such as ice or snow. The NEC also specifies the types of cables that are permitted to be installed in cable trays. Generally, cables that are specifically listed for use in cable trays, such as TC tray cable, are permitted. Other types of cables, such as THHN and XHHW-2, are also permitted, provided that they meet certain requirements. The NEC requires that conductors installed in cable trays be protected from physical damage. This can be achieved by using cables with a rugged outer jacket or by enclosing the conductors in conduit or other protective raceways. The NEC also provides guidelines for the ampacity or current carrying capacity of conductors installed in cable trays. The ampacity of conductors must be derated if they are installed in close proximity to each other or if they are exposed to high ambient temperatures. In addition to Article 392, other articles of the NEC may also apply to cable tray installations, depending on the specific application. For example, Article 310 covers the requirements for conductors for general wiring, while Article 300 covers the general requirements for wiring methods. It is important to consult all applicable articles of the NEC when designing and installing cable tray systems to ensure that the installation meets all of the requirements. In conclusion, the National Electrical Code provides comprehensive guidelines for the installation and use of cable trays and conductors. Adherence to the NEC is essential for ensuring the safety and reliability of electrical systems and for complying with local regulations. Electricians, engineers, and other professionals should stay up to date with the latest edition of the NEC and consult all applicable articles when designing and installing cable tray systems. TC cable, or tray cable, is a type of multi-conductor cable that is specifically designed for use in cable trays. It is typically used for power, control, and signal circuits in industrial and commercial applications. TC cable is constructed with multiple insulated conductors that are bundled together and protected by a tough outer jacket. The outer jacket is typically made of a flame retardant, moisture-resistant material that provides excellent protection against physical damage, chemicals, and environmental factors. TC cable is available in a variety of sizes, conductor counts, and insulation types to meet the specific requirements of different applications. The conductors in TC cable can be made of copper or aluminum, and the insulation can be made of a variety of materials such as PVC, polyethylene, or cross-linked polyethylene. One of the key features of TC cable is its ability to be installed without conduit or other protective raceways in many applications. This can significantly reduce the cost and labor required for cable installation. However, it is important to check the applicable electrical codes and standards to ensure that TC cable can be used without conduit in the specific application. TC cable is commonly used in industrial plants, commercial buildings, and other facilities where cable trays are used to support and route electrical cables. It is often used for connecting equipment, powering machinery, and transmitting control signals. TC cable is also used in hazardous locations such as chemical plants and refineries, where it must meet specific requirements for flame resistance and chemical resistance. When installing TC cable, it is important to follow all applicable electrical codes and safety guidelines. This includes properly grounding the cable tray system, using appropriate cable ties and supports to secure the cable, and avoiding overloading the cable tray. TC cable should be supported at intervals that prevent excessive sag or strain on the cable. The support should be designed to withstand the weight of the cable and any additional loads such as ice or snow. TC cable should be terminated using connectors and terminals that are specifically designed for use with TC cable. This will ensure a secure and reliable connection and prevent damage to the cable insulation. In addition to its use in cable trays, TC cable can also be used in other applications such as direct burial and underground conduits. However, it is important to select a TC cable that is specifically rated for these applications. In summary, TC cable is a versatile and cost-effective solution for wiring in industrial and commercial applications where cable trays are used. It offers excellent protection against physical damage, chemicals, and environmental factors and can be installed without conduit in many applications. Proper installation and termination of TC cable are essential for ensuring the safety and reliability of electrical systems. The selection of appropriate conductors for a cable tray installation is crucial for ensuring the safety, reliability, and performance of the electrical system. Several factors should be considered when selecting conductors, including the ampacity requirements, the environmental conditions, the voltage drop, and the applicable electrical codes and standards. The ampacity of a conductor is its current carrying capacity, which is the maximum amount of current that the conductor can safely carry without overheating. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature. The ampacity requirements for a cable tray installation should be determined based on the load calculations for the circuits that will be installed in the cable tray. The conductors should be sized to carry the maximum expected current, with appropriate dirting factors applied for ambient temperature and the number of conductors in the cable tray. The environmental conditions in which the cable tray will be installed should also be considered when selecting conductors. If the cable tray will be exposed to moisture, chemicals, or extreme temperatures, conductors with appropriate insulation and jacketing should be selected. For example, XHHW-2 conductors are suitable for wet locations, while THHN conductors are suitable for dry locations. The voltage drop in a cable tray installation should also be considered when selecting conductors. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The voltage drop in a cable tray installation depends on the length of the conductors, the current flowing through the conductors, and the resistance of the conductors. The conductors should be sized to minimize voltage drop and ensure that equipment operates within its specified voltage range. The applicable electrical codes and standards should also be considered when selecting conductors for a cable tray installation. The National Electrical Code, or NEC, provides detailed requirements for the selection, installation, and use of conductors in cable trays. The NEC specifies the types of conductors that are permitted to be installed in cable trays, as well as the requirements for ampacity, dirting, and protection. In addition to the NEC, other codes and standards may also apply to cable tray installations depending on the specific application. For example, industrial plants may have their own internal standards for conductor selection and installation. When selecting conductors for a cable tray installation, it is important to consult all applicable codes and standards to ensure that the installation meets all of the requirements. In summary, the selection of appropriate conductors for a cable tray installation is a critical step in ensuring the safety, reliability, and performance of the electrical system. Several factors should be considered when selecting conductors, including the ampacity requirements, the environmental conditions, the voltage drop, and the applicable electrical codes and standards. Proper conductor selection will help to minimize the risk of electrical shock, fire, and equipment damage.